Hi, good morning, everybody, as he makes a dramatic entry from the rear. That was fine. Hi, if you notice up there, I have the weather report, or 10-day forecast, and they're talking about between today and tomorrow about 3 inches of snow. Why am I telling you that? Because if you have lab tomorrow, you're running a couple minutes late, show up. You're up to 10, 15 minutes tomorrow, I'll allow you to go over stuff on the practice problem. But please be on time. By the way, time for a generation gap thing. This reminds me of a great comedy skit by George Carlin. If you don't know who he is, I'm missing a great comedian. And he used to do the hippy-dippy weatherman. No, I'm not going to do it. Let's do a little review, talking about how molecules, the atoms and molecules are held together. An example of a molecule would be something like this, or this. We'll get in colors. But how do those atoms stay together in the unit we call a molecule? And it's by ionic bonds and covalent bonds. There are 2 types of chemical bonds, ionic and covalent. And I want to discuss this. Let's good review. Ionic bond results from the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. And you can remember over there, it's still there, invisible though, hint, know this. And then covalent bond. And it's time for Dr. White to do his favorite thing with a covalent bond. A covalent bond is sharing, holding hands, sharing pairs, number of pairs, 2, 1 or more pairs of electrons between atoms. Remember, ionic is transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms, and covalent is, time for me to do it again, sharing pairs of electrons, 1 or more pairs. And talked about the octet rule and valence electrons, because valence electrons are the most important because those are the electrons involved in forming a chemical bond, whether it's ionic or covalent. And when we talk about ionic bonds, you're forming ions, so an atom is losing an electron or gaining an electron in order one to form an ion. There are 2 types of ions. One is a positive ion, where an atom has lost electrons, give them away. And then the other type is well, let's go through how to figure out what element, what kind of ion element forms. Yeah, you can't see it, but the Roman numerals. And notice Dr. White's in living color today. Oh, that was a generation gap thing. I just didn't know you too. All right. Question is, what ion does lithium form? And test sometime in the future. Speaking about tests, next, by the end of this week, I will post by Saturday at the latest. I'll be posting in Blackboard the information about test number 1, which is coming up a week from this Friday. I'll be talking about how many pages. I just wrote it, I forgot how many, 9 with problems. What chapters? There'll be chapters 1, 2, and 3, appendix A2 and A4. And a couple things. One, the way I write my test, if you've done the practice problems, it should take you about 35 minutes. You'll have 55 minutes to take it, but you should be done, average student, about 35, 40 minutes. I write my test so the best person isn't the only one who finishes on time. Everybody should, or earlier. It's part of my golden rule, even though I was usually in science and math the one who finished first, but a lot of my colleagues, teachers would write tests that only the best could finish, and that's not right. Anyways, let's look at and also study your notes, and don't forget, free on YouTube, go to CH, I was going to do my name, but CHEMI 1105 in YouTube, and you'll see me. All right, let's get back to how do you determine what ion does lithium form. First of all, you should know lithium by now is Li, the chemical symbol. And it's an alkali metal, which means it's over here. Next, you have to figure out which is the nearest noble gas based on atomic number. And that's 3. You have 2 choices. Helium is 2 away, and neon and E is 10 away, which is closer. Hopefully you pick 2 because that's only 1 away. Now lithium has an atomic number in the upper corner that you should know, which is 3, and that tells you how many electrons it has. It also tells you how many protons it has. And it wants to have an octet. Now it turns out helium is the one exception. Its octet is 2, because you're filling the 1s orbital, which can only 10. So lithium wants to go to 2 electrons, but you keep the number of protons, and therefore now we do some math, and you have 2 times each electron is a -1, and you have 3 protons. Each proton is a +1, -2, +3, add them together. Hopefully I did it right. If not, one of you please correct me. That's a +1. The question is, show the, write the, what ion, and I could have also written show it. And when it's a +1 or a -1, which I'll show you later on, then you don't put a number, and I'm done. And lithium. Remember, once you know one member of a family or column, you know them all. And if I ask real quick, what ion does sodium form? +1. What ion does potassium form? +1. Once you know one member in the column or family, you know them all. And I believe I did one example, I'm not sure if I did, for negative ions. Negative ions are called anions. For those of you who don't know, if you look at a battery, it has an anode and cathode. The anode, which comes from anion, is negative. Cathode from cation is positive. By the way, your batteries and your cell phone, that's chemistry. My world of chemistry is your world of chemistry, and you're learning about it. All right, question would now be, what I've done, did I do chlorine already? I think I did. Oh, let's do it again. And we'll do a couple others. Question is, what ion does chlorine form? Well, how do you do it? Same thing you did before. Look at your periodic table. Each test in the final, a copy of this actual periodic table will be at the back of the last page. You can pull it off and use it. And Let's look. First of all, you have to know chlorine chemical symbol Cl. And it's a halogen. And how many, how many electrons and protons? You look at the atomic number, it's 17 electrons, 17 protons. What's the nearest noble gas? It's a hard one. Argon, that's one away. Others are much more than one, so the nearest noble gas is argon. And therefore, it wants an octet, which means it wants the same number of electrons as argon. How do you know that? Atomic number tells you how many electrons there are. Next, do you change protons? No, they always stay the same. This is my experience. I've never played with a proton changing it. I don't expect to. And now we do some math. Each electron is a -1. Each proton is a +1 to the multiplication. Add this together, I get a -1. How do I show what ion? Chemical symbol, superscript to the right. Right, left, yeah, I got it correct. And I'm done. And since you know I like to share the fun, why don't you try this one? What ion does oxygen atom form? In case you don't know, oxygen is O, that's right there. I'll let you figure out the rest. So good to see all of you trying to do this. My heart is beating nicely because of that. Gosh, that was lame. I'll never say that again. Oh, by the way, if you have any good jokes you want me to use during lecture, email me. I'll use them. All right, anybody need more time? Going once, twice? Let's do it. All right, the question is, what ion does oxygen form? Oxygen. How many electrons and protons? Look at the atomic number. 8 electrons, 8 protons. Remember the atomic number is the number up in the upper corner of the periodic table for that element. Next, you got to do something hard. What's the closest noble gas? And since I don't want to jump, I'm going to move this down. And here we have oxygen, it's at 8. Neon is 2 away. Argon is 18. Helium is 6 away. What's the closest? Neon. Oxygen wants to have an octet, so it wants to have the same number of electrons as neon, which is 10. How do you know it's 10? Because that's what the atomic number tells us. Protons don't change, and therefore, what do? We do the math. Each electron is a -1. Each proton is a +1. Yeah, it's going to write a P there, no. Do the math. -1 times 10 is -10. Same thing, +1 times 8 is +8. Add them together, get a -2. How do you show this? Chemical symbol. You can do this or this. This is the older way, this is the newer way. I like the older way, but then again, I'm set in my ways. Good habits, I don't change. Any questions on, oh, let's do one more. try nitrogen. Chemical symbol N, if you haven't learned it yet. All right, nitrogen. What's the first thing you have to know? The chemical symbol. Next, you have to know where is it on the periodic table, and it's right here in between carbon and oxygen. Probably three of the foremost elements in our life, because that's what makes up your skin and all the other things in your body, along with nitrogen. Anyway, nitrogen. First thing you have to know, how many electrons? How many protons? Look at the atomic number, 7. But it wants an octet. What's the nearest noble gas numerically based on atomic number? And if I look here, I have 3 choices. End of the row here, neon, 7 out of 10, 3 away. Argon, 11 away. Helium, 5 away. Which is the closest? Neon. Wants to have the same number of electrons, so it has a nice stable octet, and it's happy. So it's going to have 10 electrons. You will not change the number of protons. If you do, you'll get it wrong. If you know how to do that, show me, because we'll make a lot of money. No, you can't do that. Anyways, now we do some math. Each electron is a -1. Each proton is a +1. Do the math some more. Multiplication. Do a little more, add it up, and I get a -3. And the question is, how do you show that? Chemical symbol, to the right, superscript, -3, or 3 minus. I like the first way, but either one is correct. And that's how you determine ions and what elements. Now, some elements can't form ions, but I'll teach you later on, more likely, they're going to share electrons. Other elements always form ions. And the two that I can bet everything in my wallet, and trust me, I have more than $1 in there, more than $5, these two columns, the alkali metals, alkaline earth metals, always form ions. In this case, cations, +1, +2. We've already done that in class. Now, the question you should be asking is, all right, so now I know about ion. What good is that? Why should I learn about that? It's always a good question to ask. Well, let's find out. When you're forming an ionic compound, what happens? You have electron transfer. And atoms can donate electrons. In other words, I'll give you my electrons if you want them. Here, take my electrons. Or they can accept them like, hey, give me your electrons right now. And when that does, you form positive and negative ions, and you have electronic or electrical attraction called Coulombic attraction. Opposites attract. How many of you heard in life opposites attract? I know that for a fact. This is my very best friend I've known since sophomore year of high school. It's been over 50 years. I shouldn't have said that. Anyways, he's been married a long time too. And when he got married, even before, when he started dating the woman he married, I'm thinking, boy, they're like totally opposite. Totally. And they've been happily married for many decades now, but they're so different. but they get along. That's a beautiful thing. Well, atoms form ions, and opposite ions attract to form chemical bond, ionic chemical bond. Remember, everything on the screen is available to you on Blackboard. Everybody got it written down? Who wants to write it down? One wants? It's my number. I got a fast mouse. So when this happens, I want you all to get a stiff neck, so I'll lower it. When it happens, you form ionic compounds. Positive and negative ions are held together by strong electrical attraction between opposite charges called ionic bonds. I'll never ask you this on a test, but you should be familiar with it and know what it means. Let's look a little about ionic compounds. Ionic compounds are in our daily life, and everything on the slide, I'm turning the switch, will be on the test, click to the off position. That's good stuff to know. Ionic compounds have very high melting points, 500 to 2,000 degrees C. Real quick, conversion, that's over 1,000 to 4,000 degrees Fahrenheit. Guess what? My oven at home doesn't go that high to 1,000 degrees Fahrenheit. No way, it burned down my house. And it turns out ionic compounds are good conductors of electricity when molten or in solution. I'll teach you what solution means later in the semester, but that means when it's dissolved in something like water. The water you get from the city, from your home sink, has ions in it. And because of that, it conducts electricity, which is why you should never take anything electric into water. Like you don't take your hairdryer into the shower, because that will kill you, because it conducts electricity into your body and then destroys your heart. How it does it, I'm not a medical doctor, but I think you know about dying from electrocution. And it consists of ion charges. Click, switches on. All right, now when you form an ionic compound, there's an important thing. The formula of an ionic compound indicates the number and the kind of ions that make up the ionic compound. Now, the important thing, and notice I even have it in red, is all molecules. And the sum of ionic charges in a formula is always 0. And this is something very important. By the way, the larger I write something on the board, the more important it is. All molecules have a net 0 charge. And this affects what ions and how many ions are in a compound that has ionic bonds. Let's take a look at one. You're all familiar with sodium chloride table salt. Sodium chloride has 1 sodium and 1 chlorine. How come it doesn't have 4 sodium and 3 chlorine? Or 2 sodium and 8 chlorine? It's because all molecules have a net 0 charge. Now, turns out sodium always forms a +1 cation. Chlorine forms a -1. Where does it get that extra electron? From the sodium. It transfers an electron. You don't write it this way, but it actually is that way. Next time you have some salt you're putting on your french fries or whatever, think about it, it's made up of ions, sodium plus, Cl minus. Now, the important thing, all molecules have a net zero charge. What does that mean here? Notice this is a +1. This is a -1. High level math time. Add them together, what do you get? 0. That's why you only have one sodium and one chloride ion. Because if you had 2 sodium and 1 chlorine, that'd be a +2 and -1. It wouldn't add up to 0. All molecules add up, have a net zero charge. And therefore, that's why it's sodium chloride. Now, let's take a look at something. Subscription formula. When you have a chemical formula, notice there's a 1 here and 1 here. When there's a 1, you don't write it down, but you assume it's there. The formula of any ionic compound has a 0 overall charge. The subscripts of the formula are used to obtain a 0 overall charge. So let's take a look at this. For those who have mastered my handwriting, let me translate, write the formula for the compound formed from the following ions, and you have A, B, and C. A is that. By the way, 3-point C, that's important. Now, how do you do that? How do you determine the formula for a compound made from calcium +2 and chloride -1? Good question. Here's how you do it. All molecules have a net zero charge. It even says it on the board, so it must be called that. Never mind. But anyways, it is true. This is a +2. The chlorine is a -1. Everybody see where I got the numbers from the chart? It has to add up to 0. Does it? No. Well, you can't change the charge, but you can change how many there are. How do I make that add up to 0? First of all, I put a better bracket here so it looks like a bracket. If I put a 2 there, now this will add up to 0. And how do you use this knowledge to write the formula? You take 1 calcium, and how many chlorines? 2. How do you show that? Subscript to the right of the chemical symbol, 2. And it turns out calcium chloride is a molecule that has 1 calcium and 2 chlorines. Why? Because all molecules have a net zero charge. When you have these 2 ions, you can't change the charge. Students try to do that, and it's always going to be wrong on the test. Trust me, always will be. But you can change how many you have. Oh, side note, calcium chloride, where do you find that in your daily life? How many of you seen the little white pellets you throw on the ground to melt ice? That's what you're using. There's two things that will melt ice that we use on our streets and our sidewalks. One is sodium chloride, rock salt, which works down to about 10 degrees, 15 degrees Fahrenheit to melt ice. Below that, it won't work. This goes down much lower. And I'll teach you that it's because of the colligative effect that's later in the semester. But when you go to big box store like Home Depot, Lowe's, or Menards, and I have in my garage a big bag of this. I don't buy rock salt anymore because this way, no matter what temperature, I know my driveway ices up, this will melt it. And I know when I use it, I think, oh, 1 calcium, 2 chloride ions. All right. Why don't you try this one? What would be the chemical formula of a molecule formed with 1 magnesium plus 2, or with a magnesium plus 2 and an iodine minus 1? For those of you who had lab yesterday, know I'm learning names, and for those who have lab tomorrow, I'll be learning more names. And before you know it, you'll all be real people, no longer anonymous students. Remember, when you're done, look up and smile. Ooh, it works. Sometimes. All the time, almost. All right, anybody need more time? Let's do this. How do you do this? Well, you look at the charge of each ion. This is a +2. This is a -1. How do you know it? From the superscript to the right. Does that add up to 0? And the answer is no. How can I make it add up to 0? Well, you can take and change how many of each ion is in the molecule, because you want this to add up to 0. And the only one, you can't change the charges. Students like to do that, you can't. And if I put an 2 in there, +2, 2 times -2, it adds up to 0. How do we show that? 1 magnesium, 2 iodine, and that's how you do it. Oh, let's do another one. These are fun. Try this one. Write the formula for the compound that's made up of sodium plus ions and oxygen minus 2 ions. Those who came in late, make sure you sign in before you leave today. At the end of class, we'll sign the list that's over here. All right, looks like anybody need more time? I see a few numbers still going down. I'll give you another 2.8 seconds. 1, 2, 2.2, slow clock. 2.5, 2.8, time's up. All right, how do you do this? You know that all molecules have a net 0 charge. Therefore, if I look at this, a sodium is a +1. Oxygen is a -2. Does that add up to 0? And the answer is no. How do I make it add up to 0? I can't change this, but I can change how many. If this is a +2, a -2, it'd be nice if this was a +2. How do I do that? High-level math. Now, +2, -2, 0. How do I show that? This tells me that in sodium oxide, that's the name of this molecule, there's 2 sodium, we show it this way, and 1 oxygen. And that's how you do ionic charges and write the formula. 3 points each. And I've done this writing ionic charges formulas from the charges. Continuation of the concept that the subscripts of the formula are used to change, are used to obtain 0 overall charge. In other words, a net 0 charge, which we just did here. I'm going to skip naming and writing of ionic formulas. And this one too, I should have taken this out. All right. Think about a dial that I can turn to 10. And I'm stealing this from the movie Spinal Tap, but it's a good thing. I've just turned that dial to 18. Even though it only goes to 10, I've turned it to 18 for this slide. There's an important type of ion, and we call that a polyatomic ion. And one of the things, I don't know if I told you, you're going to learn a lot of neat words you can impress your friends, neighbors, and loved ones with. And poly means many. She just passed away, it's unfortunately a lot. At the other school, there was a dean who I knew. Her name was Polly Nash. And when I was first introduced to her, I did the dumbest thing I shouldn't have done. I said, "Oh, Polly, you know your name means many in chemistry?" And she gave me that look like, you know how many million times I've heard that? And it's from Greek poly, many. Poly, many. Atomic, atoms, elements, ion. What does that mean? That means you can form ions that are a group of atoms that have acquired electrical charge, a plus or minus charge, which are shared among the atoms in the group. I will never ask on a test what's a polyatomic ion, but I expect you to know what it is so you understand other test questions and other things you should know. So polyatomic ion is an ion where you have a group of atoms held together in a unit that has an overall charge to it. So it's an ion. And you can have plus ions, cations that are polyatomic, and minus anions. I'm not going to do the naming. All right, this is important. Let's look at this chart. Here's an example of various polyatomic ions. When I say know these names, just be familiar with it. In the past, I'd ask students to memorize it. I won't. But just be familiar with it. Now, let's look at a couple of them. All right, if we look at the first one, this is nitrate ion. And nitrate is 1 nitrogen, 3 oxygens held together with a negative charge. Polyatomic, notice there's more than 1 atom here. It's an ion. Now, let's look at something. Why don't you try this? What formula would you write for the chemical formula for ion molecule formed from sodium plus and nitrate minus 1? those of you who have lab tomorrow, let me remind you, make sure you wear the proper clothing, which means no slits or cuts in your jeans, leggings, or things like that. Also, make sure you have no open midriff, even though it's winter still. And not that I'm a prude, but there's rules here. And don't forget to bring your to-do list. Don't forget to bring the lab that's due tomorrow. And don't forget to bring yourself and your safety goggles. All right, let's do this. How do we do this? We know that all molecules have a net zero charge. This is a +1. The nitrate is a -1. Oh, it adds up to 0. How do we do that? How do we show that? 1 sodium, 1 nitrate, and that's sodium nitrate. How many of you have heard the last decade, it's been in the news off and on, that sodium nitrate, which is in certain packaged meats, like salami, bologna, and stuff like that, it's dangerous for your health. How many of you heard that? It's been in the news. I don't subscribe to that because I've been eating salami and hot dogs all my life. Oh, look at it. Yeah, this thing. No. I don't know. I tend not to believe that because humans have been using that as a preservative for many eons. But I might be wrong. But that's my personal opinion. But if you look on the back of a package of bacon, it'll say sodium nitrite or sodium nitrate at the bottom of the label for hot dogs. That's used as a preservative. How does it preserve it? I have no idea. That's biology, and I'm not a biologist. There's nothing wrong with biology, but that's not the area I decided to specialize in. Now, let's try another one. And I'll do this one first, and I'll let you try it. What would be the formula of a molecule with calcium +2 and nitrate -1 ion? Well, how do you do that? You remember, all molecules have a net zero charge. It is important to know that. And therefore, if I come over here, I have a +2 calcium, and this whole polyatomic ion is a -1. It has to add up to 0. Does it? No, it doesn't. So what do? Well, you can't change the charges, but you can change how many there are. And if I want this to add up to 0, +2, this needs to be a -2. Well, if I have 2 of them, I will do that. Now, how do you write that? This is why I've done this example. We've talked about it. I have 1 calcium, but how do I show I have 2 nitrate polyatomic ions? Good question. Thank you. Well, you put a bracket, and then the polyatomic ion inside the bracket. Awful looking bracket. That's better. How many of them do I need? 2. To the right and subscript. That means under. This is still right. I'll put a 2. And that's how you show a polyatomic ion when you have more than 1. Now, the other way you showed it still works. So now, if I ask, by the way, if it gets noisy back there, and if I can hear it, you can hear it even better, feel free to close the doors at any time if it gets noisy. I probably won't hear it. Now, I would ask you, write the formula for sodium +2 +1 sulfate, SO4 polyatomic ion, which has a -2 charge. All right, let's go ahead with this. Some of you are having a little difficulty. So let me do this and then I'll do another one. Now, what do you need to know? You need to know all molecules have a net zero charge. So this is a +1 ion, and this is a -2 polyatomic ion, and it should add up to 0. Does it? No. This is a -2. This would be nice if that was a +2. I can't change the charge, but I can change how many of them I have. And therefore, I'm going to have 2 of them. Now it adds up to 0. +2 -2, 0. And now all the charges, this molecule, have a net zero charge. How do I write this? Well, this tells me I have 2 sodium. How do I write 2 sodium? Like that. It has 1 polyatomic ion. When there's 1, you don't need brackets, and I'm done. This is called sodium sulfate. How many of you see when you buy electronics or optical stuff like a microscope or binoculars or a flash drive or other things, or you got your cell phone, you know how they have the little packets in there that say, do not eat this? What those little packets are sodium sulfate. Sodium sulfate has a way of absorbing moisture. I'll teach this later in the semester. And they put that in there to keep moisture out of there so it doesn't ruin that device or whatever you're buying before you buy it. And that's what they do with sodium sulfate. And let's do this one. If I have, what would be the formula with a sodium plus cation, and it's called the bicarbonate anion? What would be the formula for that? All right, you got 10 seconds because time's almost up. Time flies when you're having fun with ions. Time's up. Put down your pencils, hand in your phone, practicing for next Friday. Not this Friday, next one. All right, this is a +1. This is a -1. It adds up to 0. Hold on, give me a minute. And the formula is this, called sodium bicarbonate. You know it as baking powder. I'm sorry, I went a whole 20 seconds late.